The Spearman Rho correlation test is a non-parametric test used to examine the strength of nonlinear correlation between two variables with ordinal data. It can also be used to replace the Pearson correlation test when the continuous data is not normally distributed. In correlation between variables, the variables are not classified as a dependent or independent variable. Correlation is a non-causal relationship which is represented by a double-headed arrow between the two variables. The value of the Spearman Rho correlation is called Rho. The result of a correlational study is either a positive correlation, a negative correlation, or no correlations. A positive correlation indicates that the value of one variable increases when the value of the other variable increases, and vice versa. On contrary, a negative correlation indicates that the value of one variable decreases when the value of another variable increases, and vice versa. The Spearman Rho correlation coefficient is ranged from -1 to 1. Table 1 presents the strength of Spearman Rho correlation coefficient. Spearman Rho correlation test can be used for predicting the relationship between variables, examining the test-retest reliability of a research instrument. The following is a research example of data analysis using the Spearman Rho correlation test in predicting the relationships between variables. In this example, a researcher investigates the correlations between four variables: commitment, engagement, academic honesty, and stress. The respondents are 70 academic staff randomly selected from a university population. In this research, the research design is correlational design. In correlational design, each of the variables, commitment, engagement, academic honesty, and stress, have three measurement items in 1 to 5 points like a scale. The objective of the research is to investigate whether there are correlations between commitment, engagement, academic honesty, and stress among the academic staff. The research question is, are there any correlations between commitment, engagement, academic honesty, and stress among the academic staff? The four variables are connected with double-headed arrow to form the conceptual framework of this correlational design research. A survey questionnaire is used to collect data from the research sample. It has 12 items. The data collected is tabulated. We will use this data for analysis in SPSS. Before analyzing the data, the researcher needs to state the research hypothesis for hypothesis testing. There are 6 hypotheses about the correlation between the four variables, which are between commitment and engagement, commitment and academic honesty, commitment and stress, engagement and academic honesty, engagement and stress, academic honesty and stress. In hypothesis testing, if the p-value of the Spearman Rho correlation test is larger or equal to 0.05, the null hypothesis is true, and we will report the result based on the null hypothesis. However, if the Spearman Rho correlation test results show that the p-value is smaller than 0.05, then the research hypothesis is true. We will reject the null hypothesis and we will report the result based on the research hypothesis. This concept must be very clear before we analyze the data in SPSS. The Spearman Rho is a non-parametric test, so it does not have assumption on normality and linearity of the data. In other words, there is no need to check for normality and linearity of the research data. Now we will analyze the data with SPSS. To enter the data, put the data in Microsoft Word at the left side. Put the SPSS at the right side. In the data, the first column is the respondents' numbers. Then we have the 4 variables: commitment, engagement, academic honesty, and stress. Each of the variables has 3 items. To enter the data into SPSS, click the Variable View button. The first column is the name column for naming the variables. Commitment has 3 items. We will type the name commitment 1, 2, and 3 for them. Type commitment 1, commitment 2, and commitment 3. Only a single word is allowed for the name. For engagement, type engagement 1, engagement 2, and engagement 3. For academic honesty, we use the word honesty. Type honesty 1, honesty 2, and honesty 3. For stress, type stress 1, stress 2, and stress 3. We have named all the variables in the SPSS. Now we move to the label column. To label the statement for each item, we refer to the questionnaire in Microsoft Word. Highlight the statements of the 12 items. Right-click and select Copy. Then return to the SPSS. Highlight the label columns. Right-click and select Paste to paste them. Now all the statements are pasted in the label column. They are pasted. Now we move to the value column. Note that the items are using the 5-point Likert scale. Click the right side of the cell, type 1 and strongly disagree. Then click the Add button. Type 2 and disagree. Then click the Add button to move it into the box. The process is repeated to label the other 3 Likert scales. we have successfully labeled the Likert scale. To label the scale into the rest of the item, right-click and select Copy. Highlight all the items, right-click and select Paste. Now all of them, the items are labeled with the same Likert scale. Then we move to the Measure column to label the scale of the data. Likert scale is ordinal scale data. Click at the right side of the cells and select Ordinal. To make it easy, right-click and select Copy. Then, right-click and select Paste to paste them. With this, we have successfully labeled the variable in the variable view. To enter the data, click the Data View button. Note that the columns are the variables name we have labeled. We return to the data in Microsoft Word. Highlight the data. Right-click and select Copy. Then return to the SPSS. Right-click the first cell and select Paste to paste them. The data has been entered into the SPSS. Let me enlarge the SPSS screen. Note that the data are in 2 decimal point 00. To remove the decimal, click the Variable View button. Click the cell and select 0. Right-click and select Copy. Then highlight all variables, right-click and select Paste. To view the data, click the Data View button. Note that the data has no decimals now. It is ready for analysis.